Hello, I welcome you to AB Math Education. Today we are looking into how we can able to write a quadratic equation whereby we have been given the vector point, how we can able to write the equation or the function of the quadratic. We have been looking at the transformations of function and realize that when it's transforming, how we can able to see is always the tip here, and that very tip is what we call the vertex. So since the quadratic and other functions like absolute have a vertex, we can, if we have been given the vertex point, we can able to write the equation so easily. So that's what we are going to look into it. And most of the time students get confused with the f of x and the y. The f of x is whereby we are talking about the function. So when we say f of x, it's just a function of a quadratic. And then we can say y, and that's where we refer to the equation. Don't be confused, all of them are the same. Quadratic is a function, so here is whereby we are talking about the function, and here we are talking about the equation. Don't be confused. So this is a general form of quadratic in the vertex form. We have different forms of it. We have a standard form, we have a fatted form, and we have the vertex form. It's three of it, and we are going to look at all of them as we are moving forward. So here we want us to write a baby quadratic function in the form of a vertex, whereby this function has been moved 1 unit left and 3 up. So 1 and then 3 up. If the point is over here, if the vertex come here, can we write the equation? The equation is right here. It's right there. Since it's left, okay, so it's going to be right here and here. So it's going to be -1 and then 3. That's where it's going to be here. We want us to see if we can able to write the formula for that. So in our previous lesson, we gave you this x plus or minus h all squared plus or minus k. And we said this is up, this is down, this is left, and this is right. So since they are talking about that, it's just going to, the equation is just going to be x. It's left, so plus 1 all squared, and it's up plus 3. And that is the equation. So we can go back to our Desmos, and then if we type this one in there, realize that it's going to go through that point. So plus 1, close it, squared, and then plus 3. You see that? It goes through that point. That becomes the vertex of that new baby function. So we have able to write it that way. So moving forward, we are doing more for you to see what we are talking about. So now let's go here. This time around, they are giving us in the form of a point. Remember over here, they were saying left and up. We're able to module. Now, if you have been given as a point, it's have to be easy peasy. And you have to be able to write the equation. Remember the general formula is a minus of that and then plus k. The reason why this formula we have the minus here is that most of the time it's behaving opposite. Because when we say left, you might think that, oh, left have to be negative. No, it have to be positive from our first example. So because of that, the formula always have a negative. But here it's plus, because when it's outside, the way we will tell you it is, that's how it's going to behave. So that is a positive, because negative is a star that always switch something, because negative times negative is positive, positive times negative is negative. So that helps to get a different left and right idea. Yeah. So here we got a point, and remember, yeah, this is a point. The point is h and k. So here h is equals to -2, and k is equals to 3. So therefore, as we are having our function, here they didn't give us any information about the a, so a is going to be 1, so it's just, we forget about it. Here, this minus is already there, and then there is another, this one is negative, okay, or squared, don't be confused, plus 3. Now here it becomes negative times negative, that make it positive. Don't square it because the square is outside, it's not within here. Yeah, so we get x plus 2 or squared plus 3 as a new function. If we want equation, don't be confused. All that you have to just change is that y, okay, or squared plus 3. So in some cases, I tell my student that y is the same as what? F of x. And it's the same as g of x. Don't be confused. This is equation. When we want to represent with equation, we say y. When we want to talk about a function, we use f of x, g of x, h of s, and so forth, so forth. So one more, we are going to use this Desmos for one more demonstration, and then I will do away with it. I'm going to grab this equation, which is into parentheses x plus 2 or squared plus 3. You see that we have able to grab this, and let's look at the vertex point. You see that? So this is the idea that if we have the point, we have to be able to write the equation. When we graph it, it have to go through that point. Okay, so at this moment, you can practice this. Is the same idea as we did the other one. We are just using the equation. We are using the function, which is a x minus h squared plus k. Remember our h is equals to -5 and our k is equals to -1. They didn't give us any point that is going to stretch or whatever, so we are going to do away with that. So f of x will be equals to this one. Since it's negative, negative times negative is going to be positive, so it's going to switch into that, or squared. This is positive and this is negative. So negative times positive is going to be negative minus 1. And that giving us the function. If you want the equation, you say y is equals to that. So when you grab this, you realize that it's going to, the vertex is going to be -5 and -1 from this equation that we have able to write here. Let's look at this one. They're kind of a little bit unique because we have been given the vertex and then you have to also go through another point. And that point is here. And how do we write that? So first of all, let's use this one to get our function as we have been writing. Okay, this is a general module minus h squared plus k. Now we don't know our a. Here we are going to keep the a because here now they are telling us that this is a little bit skewed. So we don't know how it's going to, the dilation is going to be. And this one will help us to get that, how it's going to stretch or compress. So we are going to keep it. Here our h is 1. It's going to be negative. It's positive. So positive times negative is going to be negative. And then here negative, so it's going to be negative times positive, which is negative. So we get that. If we want, since we have another point and it's going to turn into equation, let me say y is equals to a into parentheses x minus 1 squared minus 4. At this point, we have been given a point. This is a point. And we know that the point is x and y. Okay? Don't be confused again. G of x, a function, and this is equation. They are all the same. Okay, so here we we change it to y so that you can get more understanding. And remember, a point is also can be written as x and y. So therefore, the first number is a x and the second number is a y. So now we are coming back right here. And when we come, wherever we see x, we are going to replace it with -2. And wherever we see y, we are going to replace it with -1. And that will help us to find our a. And the a will tell us how it's going to, the dilation is happening. So here is -1 is equals to a. And here is -2. Somebody will say, why here you didn't switch it to positive? Because there is no number here. It's like it's positive. Positive times negative is negative. So it's going to be -2 as it is. And then -1 all squared minus 4. -1 is equals to a. Negative becomes negative. I'll write it here. A. -3. -3 squared. That means -3 squared means -3 times -3, which is +9. So here is going to be 9. Then -4. Oh. We got -1 is equals to, anytime you have a variable and a number, you write the number followed by the variable. So 9a minus 4. Now we want to solve for a. So what we have to do is that we have to make here 0. Or in other ways, we have to take this one over here. So what we do is that we add 4 here and we redo the same thing here. Okay? So like we are sending it over here and it's switching the sign. Now when we do that, -3 plus 4 is 3. And we get 9a. So basically here, one number times a is equals to this. If you don't know it, what we are doing is that we divide here by 9. And we are dividing here by 9. And this turn into 1. And here we simplify and we get 1/3 and is equals to the a. So now we have able to find our a and we can put it back here. So now we get our final equation to be 1/3 x minus 1 all squared minus 4. And now from our previous lesson that we have been doing here, that tells us that it's going to what? Compress. It's going to compress because that number is less than 1, so it's going to compress vertically. You see, it's going to be moving away from the y. And you can also grab that if we want for us to see it. 1/3 minus 1 squared and minus 4. No? This is the vertex, and then the point that we got, -2, -1 right there. So you see that that point is right there, and the vertex that they gave us, so it contains all the information that we're given. All right, so let's do the last one for you to get a little understanding. So here we have been given the point and we have been given the y-intercept. Here at y-intercept, x is equals to 0. So this one, you might see is like a single number, but it's a point because we can write this point as 0, -1. So it becomes the same as we did from the previous one. So let's go ahead and write our formula. So here a, the x, here is negative, so it's going to be positive, squared, and then plus 3. And then we say, okay, y is equals to, let's imply that y is equals to a x plus 2 all squared plus 3. Remember, this is x and this is y. So wherever we see y, we put -1 is equals to the a, and here becomes 0 plus 2 all squared, and then plus 3. -1 is equals to a. This becomes 2 because 0 plus 2 is 2 squared plus 3. 2 squared, 2 times 2 is 4. 2 times 2 is 4. So here become 4. So negative 1 is equals to 4. We write the 4 first and then the alphabet plus 3. Now we bring this one over here. So it becomes negative 1, negative 3. Because 1 will make here 0. So we subtract. We do the same thing here. And that's how it's going to behave. And here becomes negative 4 is equals to 4a. We divide both sides by 4 to get rid of that. This 10 into 1, it goes away. And then here we got negative 1 is equals to a. And therefore, our final function is equals to negative 1 x plus 2 all squared plus 3. Awesome. So here, even you can remove the 1 and write it as a negative, and all that is telling us that it's going to flip. So you can graph it and then you can check all the information that we have been talking about throughout the video. That's all the time permit us to do today. Thank you very much for sticking with me to the end. Please go ahead and subscribe if today is your first time.